Welcome. Thank you very much for coming here. I think this is the biggest lecture that I gave so far in Bamberg. Very nice. When I was asked to give this lecture here, I didn't really know what to talk about. So I talk about natural language understanding because that's the only thing I talk about. But of course, this needs to be applied to what we really care about here in today's lecture. So this is a lecture on XMS language understanding. So of course, when you give a lecture on some scientific topic, you first need to have a proper motivation why you really talk about this topic. There needs to be a need for this. Afterwards, after we're done with the motivation, which will tell you that we really need this technology, I'll talk about more concrete tasks and methods, and then there's a take-home message and a summary. So this outline is not too surprising, but I still wanted to give this to you such that you know what to expect today. So let's come to a problem statement. This is Santa Claus, and when we look from the beginning of time until the end of time, which we see here on the x-axis, we observe that the world's population is growing quite quickly, exponentially perhaps. And you might have observed that the number of Santa Clauses did not grow appropriately. So there's a 1 on the y-axis there. That's the number of Santa Clauses which we had from the beginning of time until the end of time. This is a problem. The number of available Santa Clauses did not grow appropriately to the customer base. This leads to a problem. There has been previous work on solving this issue. People scaled up the number of Santa Clauses. So you can scale up the number of people working on XMS-related tasks. The problem is that this is just a linear growth of Santa Clauses versus we have an exponential growth of the population. Also, this is a bit difficult when it comes to the observation that we currently have a shortage in labor. So we observe that the world population is still exponential and the number of Santa Clauses is still linear. Interestingly, at the beginning of time, the number of Santa Clauses was higher than the world population. There might be another approach. You could assume that you could essentially scale up the number of Santa Clauses in a different way, perhaps exponentially. So you scale up the number of workers, for instance, to have 1 Santa Claus for each household. That comes with potential issues because then the Santa Claus that needs to do the work for the household is very close to this household. And that might lead to recognition of the Santa Claus. That's not what we want, right? That takes away all the fun in this Xmas thing. So we have a desideratum that we want to fulfill. We have a problem. We cannot scale up the number of Santa Clauses. That's problematic. The solution is we need to increase the efficiency of each Santa Claus, 1 perhaps. This allows to maintain a personal distance to customers, so we don't have the problem that I visualized on the previous slide. And of course, natural language processing is the solution to that. That's probably not a surprise. So, I mean, it's the solution to everything. So we need to solve XMS-related challenges with natural language processing. So what I would like to suggest in today's lecture is that we develop an XMS natural language processing module that we can use to automatically process XMS-related texts and then automatically achieve an XMS language understanding. So we observe that there are many XMS-related tasks, and most of them, or many of them, are language-related. We would like to support XMS business with natural language processing technology, and if you're interested in contributing this, please send me an email under xmas at klngr.com, because the other top-level domain was not free. We essentially don't pay with money. We pay with bachelor or master's degrees, and in exceptional cases, perhaps with PhD degrees or habilitation degrees. We are also considering to implement a new study program at the University of Bamberg, which would be called Master of Science in XMS Language Processing. We hope that this can start in this winter term of 2025. We did not find it appropriate to have summer lectures. So let's come to the content of the task that we would like to solve. There is an XMS natural language understanding life cycle which motivates various specific natural language understanding tasks. Life cycle. We start with life. Based on life, we would like to have moral behavior. That's important in the XMS content business because we would like to reinforce moral behavior. we would like to convince the people who give us presents that this moral behavior actually took place such that they give us good presents. This might be a bit of a drastic way, but that's what Dal-E thinks is a good argument. Then we would, once we convince the people who give us presents that we are behaving in a moral way, we write wish lists such that we can retrieve our presents. And once we are done, we are either positively reinforced in our behavior or punished based on the past behavior. And each of these tasks motivates natural language understanding processing technology. So we'll start with moral behavior. So we would like to automatically analyze if somebody behaves morally. This is something that we can do with natural language understanding. We would like to assess if somebody behaves morally. So the first thing that we need to do when we define a natural language understanding task is that we need to define a label set. So now, as a computer scientist, we perhaps don't know too much about moral behavior, so we need to look into other research areas that worked on this. And luckily, we find a definition of moral behavior in other disciplines. So, for instance, this is the visualization of the Schwartz model of human values. And essentially, if we follow these values, then that could be considered moral. So we should aim at growth, we should aim at self-protection, we should have a personal focus and a social focus with various subdimensions. So that would be essentially a hierarchical text classification task. Now, we know what our label set is that we would like to apply. The question is what kind of data we could use. So which data could we use to assess how moral you behave? Any idea? Yeah? Yeah, you could use very dedicated data, which you somehow collect on purpose for this task. I would actually suggest that you just use your social media data, because as we know, people just like show their best like communication way, their best behavior in social media, right? So this is probably a good thing to use. So what we could do is we could essentially judge the goodness of a person based on the average value of the post, based on these different labels. That should work. Perhaps a baseline could also be what dominant platform you use. Perhaps people who predominantly use Twitter are just generally not as good as people who use Blue Sky. But I mean, that is something that we could debate, and it's also part of this project to evaluate this. There are, of course, challenges here. How can we identify which actions on social media provide information about moral behavior? That could be modeled as a retrieval augmented generation task, or perhaps a reinforcement learning based filter. And one might bring up, I don't think this is a realistic problem, but one might assume that assessing moral behavior on social media comes with ethical issues. However, I think this is not a big deal. Now we are able to assess how good a person is automatically. Perfect, that's a big deal in Xmas. So now we need to convince people that we do that we also did behave in a proper way. So as I already said, this argument might be a bit drastic, but for visualization purposes, I think it shows what we want to do. So what we have now is we have a computational argumentation task. We need to argue that essentially what we do is moral behavior. So we need to essentially automatically generate convincing arguments. This comes, what makes an argument convincing? Well, we can just measure how convincing an argument is based on the general value of the presents that we receive. So if we argue well, we get better presents. There has been work on this. We can build on previous work, not in the Xmas domain, right? Xmas language processing is novel. I essentially instantiate this today. But there has been previous work, particularly for persuasion strategies in advertisement. And people looked there into different categories like make something scarce. Yeah? So if you say that something is scarce, more people want it. Yeah? You could also use persuasion tactics like foot in the door, or you appeal to social identity and all these things. These are features, right? I mean, feature engineering is out. We don't do that. We optimize models end to end. Who cares about these features? So essentially, we would like to have an argument generator to optimize the value of presents that we receive. This is a reinforcement learning problem. So we want an agent. This agent is an argument optimizer. We take actions in this reinforcement learning-based agents, and these would be paraphrase operations. The states in this reinforcement learning problem are argument formulations, and the reward is the cumulative value of presents received based on an argument. Is this clear? I mean, there will be assignments, right? I mean, so we could quite easily implement this. We need seed arguments. So a seed argument could be, give me a good present. Then we run our argument paraphraser, the agent, and perhaps this paraphrases this in an initial version into please present now. Perhaps this is not too convincing, but perhaps another paraphrase could be, give me a PlayStation and I'll stop being annoying. And then we need to check the reward to understand which of these paraphrases is better. And so perhaps for please present now, you get a PlayStation 1. And for give me a PlayStation and I'll stop being annoying, we get a PlayStation 4, I think. Not the best, but I mean 5 was out. Then we calculate the value of these things. We feed this back into our argument paraphraser and can optimize this paraphraser, for instance, with preference learning or some other algorithm to optimize the parameters in there. And we have an argument system. So this can then generate good arguments like give me your bicycle or I shoot you, see this as a future investment in my success, it's more blessed to give than to receive, or give me your phone, it's safer with me. Yeah? So that seems to work in a prototypical system that worked quite well. There are, of course, challenges. There's a very long reward delay. Yeah? So when I utter an argument until I get the reward, there might be multiple months. That's a challenge for such systems which run on the long term. There are also very few reward evaluations per year. Traditionally, there's only one Christmas per year. We could include birthdays. We could also increase the number of Xmas per year. Somehow that might work. There's still also the question why this is somehow useful for Santa Claus. And we might need better funding agencies for our presents because the average value of presents might increase over time. Should, right? So now we know how we can successfully convince our present providers. Now we write wish lists. So the use case is pretty clear. We could just calculate or build a named entity recognition system and linking. When we automatically find the entities in the wish list and link this to a database storage, we could automatically order the products that we need to have on this present storage with these funnily merged animal Santa Claus helplings here, and they could essentially make sure that we have the presents on stock that people actually want. The use case is pretty clear. We need to populate the present warehouse. The challenge is domain adaptation and personalization, and perhaps the general system just does not work across users. Also, perhaps generalization across users' age might be difficult. So, for instance, your first wish list could look like this. You want to have teddy bear and a die and a bicycle. And nowadays, perhaps you want expensive holidays, a house and a car. So perhaps this is a domain adaptation problem such that the system works in general. So now we know we can automatically extract the presents that we need to order, which is an important step for Santa Claus. And now we come to this reinforcement or punishment. So when it comes to these topics, it's quite likely that there's a high incentive to lie. Yeah? So we observe that Xmas generally involves lying. So for instance, this person here might say, I'm really, really happy about these socks. Really. And you need to decide if you want to believe this person. I just see they're also not the same. Anyway, if somebody gives you a towel, you might want to say, oh, sure, I definitely need another towel. I don't have enough yet. Yeah? And this guy doesn't have a face. And perhaps you say, yes, Mom, thank you. This jacket is absolutely fashionable. Which you can debate. Actually, I prompted for ugly jacket, silver with yellow dots, and it doesn't come out so bad. But I wasn't able to get something worse. So now, luckily, there is related work on this. We actually work on deception detection in our group. This is a paper that we published recently where we looked into the entanglement of factuality and deception in a German corpus. Now, you might ask, how can we detect deception? And there's quite a lot of previous work. So what you observe that when you lie, when you try to lie, what you often do is you reduce the self-references in deceptive statements, and that suggests that liars try to distance from their selfhood. So as an example, instead of saying, I like this jacket, you might say, many people might like this jacket, to essentially take the focus away from you. It's also observed that people who lie have a tendency to make very long texts, provide a lot of details such that nobody asks about this because you wouldn't know how to answer, right? It's a lie. So perhaps if somebody says, this is really the best jacket I ever got, but you know, it's been a long time I had a jacket and this one is really beautiful. I like this because of the color, and look at the color. Wow, this is really good. I do not know how to thank you. Then this might have an indication that it's a lie because it just provides so much information. So if we have a lie detection system, which we could, of course, train based on machine learning, the value is pretty clear. As a present provider, you want to recognize a lie to improve the present quality. As a present receiver, you want to improve your deception strategies to make the present provider happy. So now we are done with this Xmas life cycle. We did this whole thing once more, and now essentially after Xmas is over, life starts again, and we need to make sure that we behave in a moral way. So now that's already everything I wanted to say today. So as a take-home message, we observe that Xmas language processing is a technology that can help across real-world tasks. I mean real-world like Santa Claus-related tasks. And we observe that through this interactive optimization of present choice, present availability, and an optimized feedback, we could improve everybody's happiness. And one might argue that improving the average happiness of people is what Christmas is about. So I hope I convinced you that these technological choices that I presented today are actually useful. And with that, I would like to end, and I hope you have some nice holidays. Do I take questions? Okay, so I was told that I can also take questions if you have any. I didn't lie, I have all the details. Yes, please.
How much electricity do you think will this project consume?
How much electricity it will consume? Too much, such that my automatic assessment of moral behavior still gives me a positive value, I guess. But very good question, thank you. Yes, there's another question.
On one of the slides I saw a hybrid between Santa Claus and an elk, like a centaur.
Yeah.
Do you think this is also a valuable approach to improve efficiency? Here, across here.
Yeah. I think generally that might work. However, I assume that scaling up the number of elks exponentially is still as challenging as scaling up the number of human workers. But I think we need to, I'm happy to discuss this further. Sean.
Yeah, so you noted at the beginning that the world population grows exponentially, but the number of Santa Clauses remain constant. However, Santa Claus only has to deliver gifts to nice kids, not naughty kids. Do you have any evidence that the number of nice kids is also growing exponentially?
Oh yeah, that's a very interesting observation. So you're right, I made a simplifying assumption, which is that essentially the ratio between nice and non-nice people stays constant over time. I mean, also an observation is that some of the tasks are independent of the niceness. I mean, we first need to evaluate how nice somebody is. Yes, I think I agree. This is a simplifying assumption. So perhaps it might actually happen that our reinforcement learning agent over time will optimize for bad people, because then the costs of our system would actually be reduced. So this might be a weakness of the approach. Thank you very much. I will put this in the limitation section of the paper. Yes, please.
Would it be a better way to decrease the population so we have a lower ratio as opposed to population?
I would prefer not to comment on that. Let's take this offline. Yeah. I'm also not aware of prior work in this area. Okay, thank you very much for your attention.